Apologies, a little bit later than expected. Welcome back. Right. The last three modules are really exploring practical elements of working with XCM, configuring chain, and so forth. This first one, we're just going to go through the Rococo configuration, as I mentioned earlier. I don't expect it to take too long, so we may end up combining two modules in this slot. Let's see. Okay. So, yeah, I want you to understand what Rococo is doing, how it's configuring itself, understand how real-world messages would be sent. You know, and first thing that you're going to sort of deploy properly, if you're making a parachain, is probably going to deploy it onto the Rococo testnet. So understanding how you're going to send messages there is probably pretty sensible, and understanding how you can identify errors. So probably fairly sensible thing to be doing. All right, let's think about what it is that we need to ensure. Now, this I've probably already implicitly told you this stuff, at least, but let's say exactly what we're talking about. So, no trust assumption, right? Our chains don't necessarily know or trust each other, especially if we want to open things up as much as possible. We want to allow our service to be used by as many different endpoints in this sort of large consensus environment that is Polkadot. Then we can't be assuming that any of these are trustworthy. Unfortunately, thus far, because parachain slots were so hard to come by, you had to go through this thing of like a crowd loan and slot auctions and stuff. It's relatively easy for those who are already in the ecosystem to say, well, you know, they're a parachain, they're probably trustworthy because they probably had to put down a fairly large deposit, they're probably well known in the ecosystem, and That won't be the case in the future. With Agile core time, you can launch a parachain, buy a couple blocks of core time, do an attack, and then disappear. Yeah. So you really are dealing not with like an ecosystem institution on the other side of the communication. You could be dealing with anyone, anyone who can scrape together a few dollars to buy a bit of core time. Yeah. So be warned. There's also the question of like spamming now. Again, in the past, there's only 50 parachains. You can easily just open a channel to all of them. You're probably going to be fine. You're not going to get spammed. Anyone who comes along asking for a channel, yeah, sure. Well, if it's only a couple dollars to create a new parachain, that's no longer the case, right? You could end up with tens of thousands of chains. You know, they're only around for a few blocks, but they're all asking for a channel. That's going to very quickly eat up your state space. Every channel needs a message queue, and those message queues are, you know, minimum size, several tens of K, and there's 10,000 of them. That's going to increase your state to like several hundred megabytes, and that's a big deal. That's going to slow everything down. So you've got to be a bit more careful about which channels you're going to accept requests from. Right? Which channels, which parachains are going to accept channel requests from, and only open the ones that actually make sense to open, or maybe attach a substantial fee to the ones that you're not really sure about, or maybe have a limited amount of randomer connections allowed to be opened per day. Yeah, you've got to start thinking about this sort of thing. Okay. So Rococo configuration boils down to setting up the barriers. We know what barriers are now. Setting up the teleports and trusted reserves, things that we basically the way that we recognize third-party assets. setting up the asset transactors, so linking assets into our local palettes, or linking XCM assets into our local palettes, managing the fee payment, weighing our XCM instructions properly. This is an interesting one. You might say, well, but the XCVM is the same code regardless, surely it just has fixed weights. Well, no, of course, because the XCVM deposit asset instruction, for example, this will call as part of its execution into a pallet to deposit the asset, yeah, on chain. And if you use the assets pallet as opposed to the balances pallet, you're going to have different weights. Yeah? The assets pallet will use a bigger or multiple storage entries, whereas the balances pallet uses fewer. So the weighing has to be done on a per chain configuration. And then finally, our conversion mechanisms to be able to convert account ID locations into account IDs. And also frame XCM origins into frame origins, which kind of uses the same thing, but is a slightly different operation to be doing. Okay, let's have a look at the barriers then. So it's quite a large barrier. I presume you're familiar with this tuple syntax. Basically, we can combine lots of different barriers. We do so in a tuple. Very efficient, very simple to look at. Everything is static. This is a general thing in Frame. It's static because A, it's a lot more efficient than having dynamic stuff like vectors which allocate memory. B, it is a necessarily static thing. It doesn't change. Therefore, there's no need to have it in a dynamic structure. And C, we get type safety. All of these things are well typed, and therefore, if we put the wrong thing in, the wrong type of thing in, we'll get a build error rather than a runtime error. So those are the main reasons that we use this kind of type-based configuration. It also makes it much easier to take a pre-existing configuration and put it into a machine-readable tool that would allow us to do, for example, graphical configuration with building blocks, a bit like Scratch or whatever. Okay, so barrier. First thing that we do is, if we have a weight credit, use that. Yeah. Now a weight credit is where it's a little bit like a store credit, right? It's like some weight we believe has already been kind of paid for or accounted for, and it's sort of free. We're giving it to this thing for free. When do we have a weight credit? Well, execute XCM, for example, will give a weight credit because it requires payment as part of the transaction itself, and therefore we give a credit to the XCVM, via the barrier, to basically say there's already some credit paid for. If the program is only going to use this amount of weight, then it can just go through. Next one, allow top level paid execution from. The top level is a bit of a... Top level just means that the by execution is at the top of the program. Really, if we're doing some renamings, we can drop the top level. Maybe we should do that. Anyway, so allow paid execution from everything. Everyone, if they pay, they can execute a message with us. Fair enough? Sounds reasonable. Allow unpaid execution from system, child system parachains. Yeah, child system parachains. So if this is the Rococo relay chain, it doesn't say that there, but it is. It's the Rococo relay chain. So we only care about child chains, not siblings or anything. And we're looking to see if they are system chains. If they're system chains, then we're going to allow them to have unpaid execution. Yeah. Okay. Any query responses that we know about? How would we know about them? Well, we ask XCM palette. Yeah, already mentioned that yesterday. Any query responses we know about, let them through for free. Yeah. Don't need to do the paid execution if we know about the query, if it's a query response we know about. And similarly, subscriptions. Any subscriptions we know about, any subscriptions arriving from anywhere, that's okay. Now, this is fine as it stands, but there is a potential issue with this one. If we were to do, okay, this is fine as it stands. I'm not going to go too much deeper into it, but you will. There is something that we might cover later if we get to it that would mean that this is questionable, and the basis is that we might mutate the origin, in which case we could end up with many different origins all subscribing, and then we would be offering free subscriptions to, say, lots and lots and lots of different account IDs that sit on the same parachain. And actually what we want to do is allow subscriptions from any parachain. Now, this, as I said earlier, works okay, although we still have the issue that with Agile core time, we may end up with someone spinning up tens of thousands of very short-lived chains and trying to subscribe to us from all of them and spamming our subscription tracking service. What's the solution? Basically, we would only allow subscriptions from places that we are wanting to interact with. Maybe that we are sending a message to already, or we have paid. We have put on a whitelist. Maybe we've paid a deposit for. This is part of the bigger question of who do we open a channel to? Yeah, this is kind of fine as it stands because we're assuming that it's the channel opening that is the anti-spam measure. And if there's a channel open, then it's by definition not a spamming attack, and we can just allow subscriptions from them. But that still just kicks the bucket, right? Kicks the problem down the line to figuring out who to open a channel to. Yeah. And it's like, is that question is rather unsolved. Like it's, you know, in a system where you can have tens of thousands of possible interlocutors, conversationalists, like which ones do you talk to? Which ones are you allowed to talk to you, given that it takes time and effort and resources on your part to have that channel open? In some sense, you just have to figure it out yourself. You have to like work out which chains are worth talking to, have people put a deposit down in order to open a channel. Yeah, those are the two usual ways of solving this in blockchain. Right? Either take a fee / deposit or have a whitelist. But maybe you can come up with something clever. XCM allows you to figure it out anyway. Allows you to code anything that you might want to imagine. Okay, let's move on then. XCM barrier, right? This is what I've just said. So trusted teleporters. This is the kind of teleporter. I think we can, yeah, scroll down there. So we've got a couple of locations. Rokoku, the rock location. I haven't actually covered this yet. So when we're dealing with assets in XCM, there is a convention to to identify the asset with the issuing location, like the chain that can issue it or the smart contract that can issue it, right? We just equate the two. We don't have a special extra mutation that we do on it. So for example, we are on the Rococo relay chain, which is the issuer of the ROC token. Therefore, we identify the ROC token as just here, because this is the chain. Yeah. So if we need a way of identifying the ROC token, we just say it's here. So we are the ROC token. We are the Rococo chain, and we are the ROC token. Yeah. We don't like try and stick an extra junction on the end of like the token of or the native token or anything. We just say we identify the native token by the chain itself. Now, if the chain happens to have two native tokens, then you'd have to have an extra junction on the end that disambiguated, right? That said which one of the two tokens it is. So, for example, Asset Hub has many kind of native tokens, so to speak, and it has an extra junction on the end that's like the assets palette, and then it actually has two extra junctions on the assets palette, and then it has ID within the assets palette, right? But if there's only one native token, there's no need to have the extra junctions on the end, and we just say, well, it's here. And then Rococo is I mean, this is just a wildcard that matches the ROC location, right? So it's fungibles of here, ROC location get, just returns here. Yeah. You don't need to worry about concrete, that's gone in the most recent version of XCM. So it's basically just saying a wildcard that matches specifically the ROC token. I think I can, yeah, I'm not even bothering with that anyhow. Maybe it doesn't come up in this particular bit. Okay, so now we're going to identify three parachains: the asset hub, the contracts chain, and the encointer common good chain. Very simple. The child parachain, so there's no need to go up a parent or anything, right? We're just going down. So parachain 1000, parachain 1002, parachain 1003. Yep. Those are our three system chains. Or rather, there are actually our three trusted teleporters. They're kind of system chains. And then trusted teleporters, tuple type. Actually, just three case matches. Rococo for asset hub, Rococo for contracts, and Rococo for encointer. If we look at what that means, I'll show you. Rococo for asset hub matches a multi-asset filter and a multi-location. Well, it says, look, we're matching this asset, which is just the ROC token. Yeah, it's the reason that we have to use Rococo rather than ROC location is because we want to match all of the assets that are one single asset which contains a fungible token whose identity is the Rococo location, and it doesn't matter how much the balance is. We can actually, this filter can be made very strict. We can match on the amount of token. We can say it must be at least 10,000 Rococo token to be teleported if we want. We don't want, but it allows for that possibility. Yeah, it's a totally general filter, well, matching system. Actually, our filter, what we want is just to check any amount of Rococo token, and so that's why it's relatively simple. And we get this Rococo get, that's our filter. The asset hub, that's just the multi-location of this. We have three of these for Rococo coming from the asset hub, from the contracts chain, and from encointer. Yep. One each for Rococo coming from each of those three chains. And our trusted teleporters, basically for something to be considered a trusted teleport, It has to match Rococo coming from the asset hub, Rococo coming from the contracts chain, and Rococo coming from Incognito. If we see that one of those three things is being teleported to us, we say, okay, I trust that the opposite side, asset hub, contracts, or Incognito, really did burn that Rococo token, and therefore I will mint it. If we don't see it's one of these guys, then we disregard it. It's an error, right? Because we can't trust that they did really burn it. Okay. So yes, teleporting involves trust. These three chains, I think there's a typo there, I think it's 1002, 1003, are allowed to teleport tokens, which means that we trust that if they tell us that we should be minting tokens locally because of it's a teleport, we trust that they really did burn those tokens on the other side. A little bit like in Star Trek, the teleport on both sides. The destination teleportation device would need to trust that the source teleportation device did really delete the person. Otherwise, it would be creating a duplicate, and there'd be two Captain Kirks or whatever, So that we need to know that the original Kirk was destroyed in some way, hopefully painlessly, before the new Kirk is created. And then we have this is teleporter. This is the thing that recognizes how to recognize a valid teleportation. Yeah. So we need to do the same thing for trusted reserves. As it happens, Rococo doesn't recognize any reserves, so it's a pretty simple tuple, the empty, the unit type. Okay. But otherwise, if you did recognize reserves, you would configure that type. So next up, location to account ID. So this is the thing that determines sovereign accounts. Given that there is a location that presumably is not on your chain, it could also be on your chain, but usually it's a foreign thing. How do we convert that into an account ID? As we know, as we've seen before, it's a very important component of withdraw and deposit assets. It's also quite important for the transact instruction. Transact is basically a trapdoor of XCM that allows us to do anything that a transaction on the chain can do. I won't talk about too much yet, but let's continue with the sovereign account thing. So parachains, the origins of parachains will be converted into their corresponding account, right? The sovereign account. They use this location to account ID to do that. As I mentioned before, local account origins, regular normal account origins, just here /account ID 32 will just be the alias of that. There will be that account ID 32. /account ID of Gav will map onto account ID of Gav. Dots or parachain, I don't know, Karura, no, I don't know what the Rococo thing is for Akala. Parachain of Akala / account ID of Gav will not map on to local account ID of Gav, because what that means is that we would be giving that parachain absolute privilege to speak for any account ID on the local chain, which we don't want to do. That would be crazy. Just giving away all that privilege. There is no reason to trust a parachain to speak on behalf of all of our local accounts. Right. So the account ID aliases. That's just what I mentioned before. If it's here /account ID, then it just maps onto that account. If we're coming from right. This is an old way of doing things. Apologies, things are changing relatively quickly. This is what in the previous module we saw done with describe family. Using describe family is the quote unquote correct way of doing it, but you might see this code in the from older, if you're looking through older configurations. This does a similar job, except it only works with child parachains. So this particular line gives child parachains a specific account ID. It's got I can't remember exactly how it's implemented, but it's a bit different to how describe family works. And so you end up with a different account ID. If the chain is already configured using this, then you can't use describe family on its own. You have to use, describe family has to be a bit lower so that if it's a parachain, it comes in and it will match on this one first, so that the sovereign account doesn't change, right? Because this describes how to convert a location into an account, which means if a location holds funds, they'll be held under the account that this converts into. If you change this conversion function, then you're going to change the account ID it looks for the funds of that location. And if there's already funds in a different location, because it's an older version of the function, those funds will no longer be accessible. So it's important once you fix this for any given set of locations, you don't change it. You can add new locations, that's fine, but you can't change old ones. Otherwise, those accounts, any assets that are stored in those old accounts won't work anymore. They just won't be accessible. They'll still be there, but there'll be no way that the chain can get to them. Next thing, asset transactors. So this is, again, this is how we saw an example of this in the previous module, how to take an asset coming in and do something with a pallet on our chain, right, on Rococo. This is using, again, it's an older chain. Newer things have come about in the last year or so. It's using the currency adapter. We now have the fungible adapter and fungibles adapter. So this is similar stuff happens with the fungibles adapter, but it's just not, don't use it for new code. So we're using the balances palette. The balances palette, I don't know if you've covered this already in Frame, yeah. So the balances palette hosts a single token, single fungible token, and it supports things like reserves and or holding and freezing or locking. Yeah. So first we're using the balances palette. That's the first thing. It implements the currency trait. Again, please don't use the currency trait for future code. It's not supported anymore. Fungibles is what we use, which can be version 2, so to speak. We're looking to see if it is a concrete. Right. Okay. Is concrete is an old. You'll see it in older code. Basically, we used to have two ways of referring to a particular asset. We either referred to it via its location or via a kind of an abstract name. We got rid of the abstract name thing when we moved to XCM4. So we were only ever using concrete in the first place. So now, if you see is concrete, you can mentally just drop it. It's an XCM3 concept. So we have the Rococo location, the thing that's matching Rococo tokens, and we're basically saying if we see a Rococo token, then we can use the balances palette. We can use this balances palette to represent it on chain. We need a location converter because, of course, when things like deposit and withdraw asset instructions come about on chain, in the XCVM, we need a way of converting a location into an account ID to deposit it somewhere on chain. Yeah, so that's the converter we use. Same thing as saying the sovereign account converter as well. So it's really just a conversion function that takes location, gives an account ID. I know I'm laboring this, but it's an important. It's kind of a pretty big centerpiece of XCM and XCVM. Then we just need we need this like type account ID. Just put that in there. It's just for the rest type checker. The check account. This is so that we can keep track of teleportations. If you remember yesterday, I mentioned that with teleport, although there is a very strong trust relationship, we never accept more tokens back in than we have sent out. If we are the issuing chain, we can't say the same for the other side, because the other side kind of doesn't know how many, it doesn't know how many tokens to let in because it doesn't know how many tokens exist. But the issuing chain definitely knows that at the beginning of the world, that all of the tokens existed on that chain, and therefore it can keep track of how many have gone out to not let any more back in than that. Yeah. Okay. So check account is basically the account where we store what tokens have gone out. They're not counted, they're kind of counted towards total issuance, but they're not counted towards the amount of tokens that exist on this chain. It's sort of like a phantom account. Yeah. It's the tokens that exist on other chains that we have teleported out to other chains. And the main reason it's different to like just storing reserves, like kind of wrapped tokens, is that we don't know which chain it's gone out. It could be the asset hub, it could be the bridges, it could be the Cointer, it could be any of these teleportation destinations, and then it might change. They might teleport between themselves and then eventually teleport back again. So all we do is these are the tokens that we store that are not in this chain. Yeah, that were in this chain but have been teleported out and might eventually be teleported back again. In this case, it's really just an account ID. That's all we're just taking a random, I don't know, hash of an account. Sticking it in there. Good. And then finally, XCM config. So we have to configure our XCVM, the XCM executor, with asset transactor. So we only have one. There's only the balances palette in Rococo. Yeah. If we had multiple balances palettes or other assets palettes, if we manage more assets, we'd have several of them configured in a tuple. We're looking for them to match the here multi-location. We know that we don't put the here, you don't see the here multi-location in there. Instead, you see this rock location, but that's the same thing, if you remember. That's how it was defined. Ignore the is concrete. Currency defined in balances, right? Yeah, so it's just the balances palette. One specific instance. It's the only one, but there's one specific instance of palette balances. And yeah. So this is rock, not dot. It's a typo. And we're configuring XCM to recognize that there is only one token, one native token at our location. Yeah, I mentioned it before, reiterated that. If there were multiple native tokens, then we'd need extra junctions. And indeed, if you look at Asset Hub, there are extra junctions. Okay. Yes, now, the origin converter. Now, this is useful specifically for transact. So for you to understand what this is about, you need to understand a little bit of transact. So transact is a instruction used in XCM, and it allows you to basically disregard everything that's going on with the XCVM and just go ahead and execute a transaction, right? Now, you're familiar with transactions, right? Extrinsics, they're signed extrinsics, coming generally from users, giving instructions to a palette to do some particular thing, okay? These transactions can do fairly arbitrary stuff. They're not constrained by the model that XCVM brings with it. So if you need to do something that XCVM, you really can't make work within XCVM, then you're probably going to need to use transact. Yeah, think of it as just as a trapdoor, a get out of jail free that lets you do basically anything. When you use transact, you obviously got to provide it with some weight, right? That transact has, you have to tell it how much weight you're going to use from your XCVM in order to have it be secure, right? Transactions have a particular amount of weight associated with them, and that amount of weight associated with them isn't necessarily known within the XCM weights. More importantly, when you execute a transaction, transactions execute with origins. Yeah. Might be the signed origin, might be the root origin, might be the non-origin, might be well, there's all sorts of origins. Governance origins as well, right? When the transact thing executes, it needs to know what origin it should execute with. Now, the XCVM doesn't understand frame origins, right? It has an XCM origin, a location, but it's not a frame origin. And so what we need is a way of converting the XCM origin into a frame origin. Now, there's a few origins that might seem pretty obvious. Like, for example, if you've cleared the origin and there is no origin, then it's reasonable to convert that to the non-frame origin. Yeah. Similarly, if the origin is here, this chain, it's reasonable to convert that to the root origin. Right? If the origin is an account ID here, it's reasonable to convert that to the signed origin with an account ID in there. That said, there are times where even if it is an account ID, you might want it, like here, account ID, or even just here, you might want not to convert it to the frame origin, or that particular frame origin, but rather for it to convert to the XCM palettes frame XCM origin, which gives a XCM location as a parameter to the origin. I can, I'm not going to go to, do we actually even have that here? No. Okay, fine. Yeah, no. Okay. Ignore, if you want to know more about that, have a look in the palette XCM and look for the XCM origin there. For now, I'm not going to go into that too deeply because it's a bit beyond what Rococo is doing. So let's look at the specific local origin conversion clauses. So the first one is sovereign signed via location. What this means is we're going to use our location converter. So if you remember, that's the thing, the sovereign account converter, the thing that takes a location and converts it into an account ID. And we're going to say, right, if it's just a location that's being converted into an account ID, then do the same here and put it in signed, put it in origin : signed, right? Pretend that someone has actually signed a transaction and what the account they signed it with is the sovereign account. Yeah, that's the first one. The next one is, if it's a child parachain, then we will convert it into a special frame origin known as the parachain, child parachain origin. This is like root and signed and non, right? These are the regular basic origins. But as you should know, frame origins can be extended. If your palette wants to have another kind of origin, it can introduce another kind of origin into frame, and it can be configured into the main runtime. Well, it turns out that there is such a palette that does this for parachains. So if you have the parachains origin palette, this actually has another origin similar to the system origins that are non-root and signed, but it's actually parachains, and it just lets you in frame, natively in frame, have an origin which represents a parachain. Okay. And what we do is we look for a child parachain location, and if we find it, we convert it into this frame origin to represent a parachain. Yep. Okay. Next, if we have an account ID 32 origin, and we want it to be recognized natively. So if the origin is kind of here / account ID 32, so just account ID 32, then we're going to convert that into a specifically a signed, a regular signed origin. This is a little bit different than this one. And to understand, this one isn't using the sovereign converter. It's using the, it's looking specifically for a account ID 32 only. And it's got sort of special casing that and saying, if I just see a location that's an account ID 32, and it's being converted natively, then I will turn it into a signed origin. Now, this is where you have to understand what natively means. I was kind of hoping not to get into this, but it seems that now I've been, aha, here we are, okay. This is where we have something called origin kind. When you're transacting, you, as part of the transact instruction, you give it what origin conversion mode you want. And that's this origin kind. You can think of it as like a mode of converting the location into a frame origin. There are 3 different modes. There's the XCM mode, the sovereign mode, and the native mode. Native looks for ways of converting specific equivalences between the frame origin it knows and the location it knows. It doesn't do anything sort of with the location. It doesn't try and fudge it. It doesn't try and mold it. It just says, right, if the location, for example, is here, I know there's a one-to-one mapping between here and root. Like root, in some sense, here, in some sense, really has a native representation within frame. Yeah, there's nothing special going on. There's no conversion going on. There is just an association there. Same with account ID 32. This just has a native representation in frame that is the signed. There's no sort of molding. There's no massaging happening. Sovereign basically says massage it with a location account to account conversion. Now, there are some location to account conversions that will result in the same account ID happening, the same actual frame origin happening as native, just because they're very simple, and it turns out the native form of it is the same as the sovereign. But it's a different mode because there are some locations that just have no native equivalent. There is not a frame origin that can give you, that can represent that directly, and so you have to do something clever, like hash, like represent, like do this sovereign account conversion function, describe it in a stable way, and then hash that, and then you get a hash out, and then sort of pretend that that's an account ID, and right, and you know the rest. So that's the difference between sovereign, use the sovereign account converter and turn it into a signed origin, versus native, do what If it seems to be something that has if it is something that has a one-to-one association, just use the associated frame origin. If it isn't, then you can't use anything. This is necessarily going to be more general than this, because this works basically on everything. Yeah, everything that we have a sovereign account for, which if you're using describe family and all of this stuff, is going to be a lot of different potential locations. Whereas this only works with the specific frame locations that our frame runtime supports, which is basically signed accounts, root, nobody, and maybe the parachain ID. There is a third one, which isn't covered here, called XCM. What this does is it uses the XCM palettes specialist origin. XCM palette has a special origin, a bit like, as I say, a bit like the system origins with, you know, signed account ID and non and root. Yeah, so the XCM palette has an origin, just call XCM, XCM location or something, and it has a parameter of location, right? And it's just like a frame origin whose job is to hold an XCM origin, right? So you can take any XCM origin and just lob it in there. And if the origin kind is XCM, that's exactly what it will do. It will make a transaction whose origin is the XCM palette's specialist origin, which is parameterized with the XCM origin that you're currently running the XCVM with. What this allows is for transactions, transaction types, like frame transaction type, frame dispatchables, to work with origins, to accept origins that are XCM locations rather than frame native stuff. Yeah? And there are certain times where this is very useful. But most of the time you're going to want to use, unless you know that your transaction, the dispatchable, the frame dispatchable, specifically supports XCM, palette XCM location origins, stick with native or sovereign, because these are ways of converting it into a regular, you know, account ID, signed or non or root origin that frame, almost all of frame will work with. Yeah, it's a bit in depth, but if you look at the code, it should start to make sense. Let's look at the final clause here. Child system parachain as super user. What does this mean? And this is pretty mental, but this says that if there's a system parachain, so if it's a child parachain that's like, I don't know, the assets parachain, as it happens also like the encointer parachain, then it can run as root here, right? So basically if it says origin kind native, and by the way, I'm coming from the encointer chain, it will execute the transaction with a root origin, which is, as I say, very questionable configuration. It assumes absolute trust in system parachains, which may not be such a great plan, but there we are. That's how it is at the moment. It's been running a while, so I guess it's practically speaking okay. But you probably, you know, I'm pretty certain that the Polkadot relay chain isn't configured in this way. Pretty certain this is just a Rococo thing. It can be helpful to have something like this specifically for a governance chain. At the moment, governance is done on the relay chain, and therefore, if something needs to execute through governance with root permission, root privileges, for example, an on-chain upgrade, it's easy because it's running actually on the relay chain. If governance is moved to a parachain, then there needs to be a way for that parachain to tell the relay chain, you need to upgrade yourself to this new code. And for that, obviously that needs to be very high privilege level, it needs to be root, and therefore you would need this clause in if that were the configuration. If that were the configuration of the governance system, if it were on a system chain. Basically, the governance system parachain would need to be able to run a super user if it really wanted to. Of course, you will then say, well, if the governance chain is insecure, then it's gonna potentially be able to brick the relay chain. You're absolutely right. The governance chain would indeed need to be secure because it would otherwise you would otherwise have compromised super user privileges on the relay chain, which would be very, very bad indeed. So, in general, child system parachains as super user is somewhat questionable, but probably eventually some of the system parachains at least would need to run with super user privileges on the relay. With core jam, that's less of an issue, but that's a different thing. For now, let's just consider what we have at the moment. Okay, so we're familiar with that. Next thing, the weigher. We need to understand how to weigh things in Rococo. Basically, we create, I mean, this is like, there's not much going on here. We're essentially just configuring the means by which we can run through all of the XCVM instructions, given our configuration of the XCVM, and determine what their weights should be. Well, actually, and determine what their weights are. So the XCVM, the XCM executor needs to understand how to weigh any given XCM code to understand how many fees should be paid and how long it's going to take. Yeah. So this type basically helps it understand that. And yeah, and we have within this a sort of maximum instructions. We give it the weights, the XCM weights. So this is how these get. We actually do the weighing through benchmarks. We end up with this weight structure that goes in here. Next, there's a weight trader type. So this, we need to understand how, once we've weighed an XCVM program, an XCM, we need to understand how to convert it into some particular type of fees, some particular fees. In this case, the type of fees that we're using, very simple. It's just the Rococo fees. This implies we're only going to be using Rococo to pay for fees, so it's only the native currency. As I said before, we are seeing chains being configured now, particularly the Asset Hub, that allows many different currencies to be used to pay for fees. But in the case of this rather old configuration, we really should just restart Rococo with proper configuration. We're using only the native. To be fair, on Rococo Relay, there is only one currency on there anyway, so it's not like it would make much sense to be able to pay in other currencies. So fees go into the block author, so we take the fees, but what do we do with them? Well, we might burn them, we might send them to the treasury, we might send them to the block author, we might do some combination of all of those things. This allows us to configure that, and we configure it with this to author, which is basically an unbalanced implementation. The rest of it is pretty trivial. Balances and account ID are just types for Rust's type checker. ROC location just matches to our reserve currency, which, as you remember, is here.into. The only thing that's a little bit clever is this weight to fee, which needs to be defined in order to it's just a simple conversion. Takes away, gives a fee out. There's of course a question, how do we do weight to fee? Okay, are we not doing it here? I thought we did do it. Apparently not. Okay. So the way that we Yeah. So the way that we will normally do wait to fee, maybe on Rococo, it's actually fixed. We normally do it through using the transaction fee system. So transactions internally use a wait to fee conversion as well, because they of course have a dispatchable which has a specific weight attached, and they need to know how much to charge for the execution of the transaction. So they take that weight, convert it into a fee, and charge that amount. We generally just use the same thing, but presumably in the rest of the runtime definition, this weight to fee is defined as being that. Okay, so the rest of the stuff, So we have XCM router. That's how we send messages around. In this case, just equals XCM router. That's like, do we have anything on that? No. Okay. This will just be I guess a DMP router. So basically it knows how to send messages down to parachains. This is a primitive that is given to you. So you have DMP primitive, you have a UMP primitive for sending it up to the relay chain, and an XCMP primitive for sending across to other parachains. And you can just configure the router as basically a tuple of those things. Send XCM origin. This is the origin that Pallet XCM uses to understand if it's allowed to send an XCM on to another location. This will prefix it with the descend junction, as I mentioned before, to descend into the account ID of the sender. So it's secure. It should be secure even if you allow it to everybody. And I think some chains do. We haven't yet done this on the relay chain. We just consider it just a little bit too unneeded to be doing it on such a sensitive bit of infrastructure. But it has been audited. In theory, it should be okay. We also have a similar origin requirement for using the execute XCM transaction dispatchable in the XCM palette. Again, on the really sensitive chains, we just say, no, you're not allowed. But it's been audited, it should be secure if you want to enable that. We have a filter for what XCM code you are allowed to execute. If you do enable this generally, you might want to put something in the filter that just keeps the size, the number of instructions down, or it restricts it to a particular set of programs. Again, XCM, if you've done all of your weights correctly, you set your XCVM stuff up correctly, this should be fine to use with everything. But again, it's just a case of how conservative you want to be. XCM executor, that's our XCVM, easily enough. The XCM teleport filter and reserve transfer filter, again, are just the origin filters that are allowed to use the teleportation and reserve transfer functionality. In this case, we just let everyone do that. I don't see any big... The actual XCM code that gets executed is relatively constrained, so we don't see a big problem of just letting everyone use this. But it's there in case you do want to have some sort of permissions involved with those functionalities. All right, so yeah, no filters there. Local origin to location allowed to, yeah, okay. So local origin to location is a way of doing the thing in the opposite direction to what we've been doing so far. Instead of taking a location and converting it into an account ID or an origin, we're taking an origin and converting it to a location. Pallet XCM needs to be able to do this in case we're doing something like execute XCM. Yeah, and it's like, well, how do I convert an origin to a location? I've kind of brushed over this in the past, just saying, oh, well, we just do a descend junction account ID. But in reality, this is what that is doing. It's descending into into this junction here. Basically, it's tacking this interior location onto our location, which is here. This one does something similar, but instead of recognizing signed account IDs, like the signed system origin, it's recognizing the council origin. This is a frame origin provided to us as, I mean, again, this is a very old configuration, but it's back in the Gov1 days where we had this council, this governance body called the council, and it's converting that into what XCM calls a plurality, which is basically just the concept of a governance body, but it's more of an abstract concept without reference to any specific implementation of governance. And in this case, it's converting it to plurality, and it's not saying what, it's not identifying the specific body, so it's just sort of the body, the one body, the only body. And that's it. So what this basically boils down to is in this configuration, if the council were to dispatch a transaction, were to send a transaction as part of the governance system, so the transaction comes from the council body, and it did a transaction in XCM, so it did execute XCM, yeah? Sorry, not a transaction in XCM. If it executed XCM as part of that governance resolution, the XCM would execute with the plurality, like it'd be like here / plurality. Yeah. This is different, of course, to if the governance sort of referendum executed, in which case it would be the root origin that would be the frame origin, and so it will convert to here in XCM, in the XCM origin. Although, as it stands, this configuration wouldn't do that. This configuration would just bail because it doesn't have that clause in. But that would be a reasonable clause to put in. If it's the root origin, convert to here. That clause might already be written in the XCM builder. I don't know. Sure. Good. And that's it. So yeah, I hope this has sort of given some idea about how to configure chains. Most of the stuff is unchanged. The barriers in particular are unchanged. The teleportation and reserves filtering hasn't changed. The asset transactors has changed a little bit, so we now have this fungible thing, but it's more or less the same when you're actually doing the adapter configuration. B payment has maybe changed a little bit as well. The instruction weighing, I mean, the benchmarking isn't covered here, but the actual weighing is fairly straightforward. And then the conversions, again, there's a little bit of change there, but I think most of it is still pretty relevant. Most of it is still relevant. Any questions, particularly on this stuff? Yep.
When you do the Polkadot architect, why you choose teleporting instead of a reserve pattern for the system chains?
Because if you have a reserve, you necessarily have to go through that reserve, which means if you want to, so suppose, for example, the assets chain wants to send some funds to the collectives chain. If it's a teleportation, the assets chain just burns those funds, and the teleportation, and the collectives chain just issues those funds, and it's a bilateral action, right? There's only two parties involved. If it's a reserve asset, the reserve is presumably the relay chain. And what that means is that the assets chain has to tell the relay chain, reduce the assets in my account, and then send an onward message to the collectives chain, telling the collectives chain that their account has been credited and they now need to execute some action. So now it's a tri-party thing, right? You've got the source, you've got the destination, and you've also got the reserve, the third-party reserve. And it's just less efficient, right? Why send two messages when you can get away with just sending one? Why can we get away with sending one? Well, because we're all part of the same governance. We have a very, like an absolute level of trust, more or less, an absolute level of trust, because the same governance structure can alter any of our code with the same level of security. Now, that's not usually the case, right? The usual case is, in blockchain particularly, that the two parties don't trust each other, in which case you do need a sort of trusted third party. And then for that trusted third party, we try to ensure that that third party is either the system, which we trust anyway, because we trust our parachain is secured by the system, or is the issuer, which we trust anyway, because they can just create arbitrary amounts of the asset. Okay. Good. All right, good. Let's take 5 minutes, and then hopefully we can cover the last, well, not the last, the penultimate module in before lunch. Yes.